Hello, everyone. We are pleased to be joined by Arsalan Mousavian, who is a senior robotics research scientist at NVIDIA. So Arsalan is going to be speaking to us a bit more about robotics and everything that's exciting going on in that space. So Arsalan, again, welcome to the Innovation Forum. Very much looking forward to this discussion. To
Yeah,
start,
looking forward to it. Thanks for the kind introduction, Norman.
perfect. And to start, I'm very much interested to learn where your inspiration came from to lead you to pursue a career in robotics research.
Yeah, so my love affair with robotics kind of started from undergrad. So initially, when I started studying computer science, I realized robotics is kind of the only the only subfield in computer science that you get to do actions in the real world. Like the rest of the subfields in computer science are mostly about like digital space, like you want to render an image, you want to like send a packet over the network and like these kinds of things. But robotics is very in physical world. And then I got involved in RoboCop teams where we kind of like train agents to play soccer in simulation, and we also like did well in the World Cup for like simulation soccer. But then during my grad studies, it got more serious. So I got to work with multiple robots during my coursework, and during my PhD, I did multiple internships in robotics companies. So, for example, I did an internship at Zoox, which is a self-driving company that is part of Amazon now. So I basically developed a method for predicting 3D bounding boxes for cars, pedestrians, so that the autonomous vehicle can abstract away the surrounding area, and then the higher level stacks like planners basically take these oriented bounding boxes and operate on them for planning the path. And in the last year of my PhD, I spent the whole year in Google Brain Robotics, where I worked on learning to navigate in different homes based on semantic goals. Like, for example, you want to say that, okay, you want to go to kitchen, just the agent should basically come up with a series of actions that takes the robot from different rooms to the semantic target that you want to achieve. So basically, these two internships really convinced me that I want to work on robotics, because like in university, I was mostly working on 3D vision, and we were doing a lot of benchmarks on the data sets that were useful in robotics, but I didn't deploy them in any robot. But during these internships, I got to deploy them on the physical platform, and it was a very rewarding experience. So I was like, this is the thing that I'm passionate about, and I want to pursue this.
That's wonderful. That's fascinating, and I love how the passion comes through in what you speak about as well. Now, switching gears to NVIDIA, I believe you've been there for about 5 years now.
Yeah.
I'm sure most of the folks watching this video have probably heard of NVIDIA. Definitely has been dominating the news headlines lately.
Yeah.
I was pleasantly surprised to learn that they had a robotics division and worked in automation. So can you talk a bit more and provide an overview about NVIDIA as well as the intersection of AI and robotics there?
Yeah, definitely. So NVIDIA is a very interesting company. It used to be mostly known for computer graphics and gaming, and people didn't really consider NVIDIA to be in other areas. But deep learning is kind of like all the success in deep learning and AI is built on top of the massive parallelism that you can get from GPUs. So as a result, NVIDIA is transforming toward being like an AI platform company. So what does it mean? So it basically means that we are not just selling chips, we are selling the ecosystem and software around it. Sometimes we even give out the software for free to kind of encourage adoption. So basically, NVIDIA is both making the hardware and also building the ecosystem around it. And NVIDIA research is basically focusing on high risk, high reward problems so that if they succeed, they kind of shape the future of the company. So NVIDIA research has been around for a long time, and it used to be the case that it was mostly focused on architecture research to come up with the next great architecture for computing, and also like for rendering, like for example, shaders came out of NVIDIA research. PUDNN came out from like NVIDIA research, and there are a lot of these efforts. But in the past 6 or 7 years, there is a big push toward expanding in AI and machine learning. So basically, we have multiple teams in AI space. So I'm in the robotics research. We have like autonomous vehicle research. We have teams on neural renderings and like these kinds of things. And in robotics, we are kind of we have our main focus is to enable robots to do manipulation in unconstrained environments. So we have done a lot of research on pushing the state of the art on object grasping, like segmenting objects in the scene, or like very quickly generating collision-free motions so that you can generate motions online as opposed to like pre-record the trajectories and just repeat those trajectories. And in terms of area, so we are working in 2 main directions. One direction is on manipulation in the kitchen to basically handle different objects, accomplish tasks in the kitchen. And the second avenue is, of course, like industrial manipulation, where we want to make robots easy to use in manufacturing.
Mm-hmm.
Yeah.
That's great. I want to dive a bit more about that piece right there, object manipulation, specifically within manufacturing.
Yeah.
Where do you see the future of computer vision, 3D vision, object manipulation as it relates to manufacturing?
Yeah. So 3D vision in robotics used to be heavily around object pose estimation. So you kind of say that I want to estimate the position of all the objects in the scene, and basically the planner and the high level software basically build on top of that estimate. So you kind of abstract the word and make it like a simulator, and then come up with a series of action. But the issue with that is that you need like 3D models for all the objects that you want to interact with, so that would make it not really scalable. And also, if you have an error in pose estimation, it propagates toward different toward like down the stack, and it would make it brittle. So in the last couple of years, there is a push toward directly learning the final goal position. So basically cutting the middleman, which was the pose estimation, and directly go toward predicting the goal targets. And that seems to be like very flexible. And that's basically where the research is going. So basically, you want to train on a lot of different geometry and appearance, and you want the models to basically predict the end goal position so that you just command the robot to go toward those end goal positions.
I can see that being right up the high risk, high reward alley, right? For sure.
Yeah.
Absolutely. My next question is rather specific, but I think there's some interest from our audience. How would you approach the problem of model-free object manipulation in an unconstrained environment as it relates to manufacturing?
Yeah. So model-free object manipulation is like if for any of these AI models, if you want to have a good model, you have to provide large amount of data that captures all the variations that you can see to basically make a model that generalizes to new environments. And one thing that is very important in manufacturing, actually there are two things, but I'll focus on the first one, which is robustness. Like you don't want to see a lot of failures, or if you see failures, you want to be able to, for the robot to reattempt and recover from that failure. So what and for model free, what so basically we need to have like a larger scale data, and that data needs to cover a lot of variation, because like for example in manufacturing you can have very different lighting conditions, like the parts could have stain or like some imperfections on them that would make it challenging. And collecting all that data in the real world in different environments is kind of like costly, and it takes a long time. So the thesis that we have at NVIDIA is that we basically generate a lot of diverse training data in simulation. So we create all those like lighting changes, all those artifacts on the parts in the simulator, and we basically use the simulated data to train our models. And once you deploy the models in the real world, you can also get feedback the data from the real world deployment to constantly improve the performance. Because if you don't start from like an initial model, it is hard to justify for a manufacturer to give you a space to just collect data without returning any value. So if you train it in the simulator, let's say your model works like 80%, 90% initially when it is trained in simulator. But once you start deploying it in the real world, you can use that data and constantly improve your model.
Absolutely, the iterative approach, very much so. I'm sure you've worked on a variety of various computer vision problems over your career, and you spoke a few of the challenges already. From my research, I came across different things such as object pose estimation, object detection, image-based localization, right? The list goes on and on.
Yeah.
From your experience, which of these problems that you've encountered are the most interesting and also the most challenging for you to overcome?
Yeah. So I touched a bit on pose estimation and pointed out some limitations, but we are doing some recent research on few shot pose estimation, because basically one limitation, there are two limitations with pose estimation. One is that you have to train on each part, and if you change the part, you have to retrain again, which makes it like difficult to use. And the other thing is that you don't want to have the CAD model for every single object in the world. So we pioneered this line of research, which is called zero-shot or few-shot pose estimation, where you want to train a model, where you basically want to train a model on a larger scale set of meshes and appearances and geometries. And in the test time, you want to basically, if you want to do any pose estimation for new objects, you just present few images of that object, and basically the model is able to give you pose estimates with respect to those few images that you took. So instead of going through building high definition models or going through another round of like training, you basically put all of your effort in the pre-training, and in the test time you just take few images and the model is good to go. So we are actively, so we started this line of research 2 years ago, and it led to like an explosion of the works on this area. And we are also actively working on it to make it more robust and be on par with the models that are specifically trained on a particular object.
Mm-hmm. Now, you've published several papers, Arsalan, with, it definitely has a lot of detailed expertise baked within those papers. Absolutely. If you could distill it down and pull out the most insightful findings that would be applicable for camps, could you share some of those findings?
Yep. So, so the first line of work that I can talk about is like grasping arbitrary objects, and that is very useful for in manufacturing and also in logistics for warehouse, where you want the robot to pick up any object. Like basically, let's say you have a bin that you want to sort it or unload it. You basically need this capability for the robot to pick up any object. So that was like the first project that I started at NVIDIA. So basically, you want, given the scene, you basically want your model to predict a set of goal poses that if your robot moves to those positions and like activate the end effector, it can pick up that object. So that's one line of work that is quite relevant for manufacturing and also logistics. The second line of work is about zero-shot object rearrangement, where you basically have this like target arrangement that you want to achieve, and instead of coding it up, you basically take a snapshot of the final arrangement that you want the robot to achieve, and basically the method that we developed basically comes up with a series of actions to achieve that target that target configuration. So that would make programming the robots easier, because that way we kind of abstract away all the details underneath, and all you need to do is just to take a photo, and that is like the most natural way that people can interact with like a manipulation system.
Arsalan, I have a quick question, and sorry to interrupt you, but you mentioned earlier in your PhD work you were working with the self-driving cars, and now the deep learning at NVIDIA, and the word that's coming up for me from what you're talking about is algorithms.
Yeah.
So I'm guessing that there's these deep learning algorithms that are you've seen probably a lot of change, haven't you? And the algorithms, and also in self-driving cars, I think as an example, there just cannot be any mistakes. Like when you talk about collision-free, how is the evolution of AI and deep learning making things possible that weren't possible? And it sounds like when you talk about things going from a simulation and then you do it for real, that you're watching these algorithms do their thing. Is this advancing? I mean, with all the things you're seeing with AI and deep learning now?
Yeah, definitely.
Taking over?
Yeah. So so I started my research in deep learning in 2014. At the time, it was dominated by convolutional neural networks. So you basically had this like convolution operations, and you had these like deep models that you would train your models on. But there was this like ceiling to the capacity of those models, that you couldn't compress, because basically the high level idea in AI is that you want to compress the knowledge and the structure from larger scale data sets to like a compressed model. And basically these different architectures, the capacity of the model to observe information is very important. So it used to be CNNs, like convolutional neural networks, that boosted the progress in deep learning. But these days, it is all transforming to transformers, like all these like language models and like the recent state-of-the-art in vision, they are using transformers one way or the other. And in robotics, there is also like a third category, which is also getting a lot of momentum, and we were also involved in kind of advertising it and encouraging everybody to enter into that space, and that is like processing point clouds. Because in robotics, like you can have RGB-D cameras, and depth data is also very low dimensional and gives you a lot of useful information. So we are also using a lot of point cloud and depth data. And so that's on the evolution and like progress on the learning side of things. On the synthetic data, especially with ray tracing, the quality of the renderings that we can get and like the kind of scenes that we can create in simulation are improving in terms of photorealism and quality quite drastically, to the extent that most of the models that we train in simulator, they perform quite well in the real world, and we don't even bother training, like fine-tuning them or like improving them in the real world. So it's kind of like with the advancements in computer graphics, the gap between simulation and real is shrinking quite constantly.
Thank you. That was an incredible answer to the question. And it's really thrilling, and it's hard to comprehend all of the improvements that are making what you're doing today even possible.
Yeah, like, and NVIDIA is great because like there is this like separate efforts on improving the simulators, and we are also benefiting the fruits of that effort in robotics. So it's kind of like a very good match for robotics.
That's great. Absolutely a great match. You've talked a lot about the momentum behind a lot of the advancements in robotics, right? How the gap is shrinking, and a lot of great work is happening there. Can you also talk on the flip side of that? What are some headwinds that we need to be aware of? Some potholes on the road to innovation that we need to be cognizant of to maneuver around that won't slow down progress?
Yeah. So I would say the biggest obstacle right now is that right now most of the top-notch technology in robotics is run either by people with like PhDs or like with advanced studies in that area. And I think as roboticists, we haven't done enough to make it really easy to use for everybody. And that's where I think that's where the inflection point is. Like you should be able, you should be able to give out this technology, and everybody should be able to use it without like spending years in like using robotics and like learning about like these different background or like this area or that area to be able to operate a robot. So I feel like this is the biggest obstacle for robotics right now. And the other thing is that the cost, like we need to bring down the cost of deploying these systems, because right now, I mean, like the cost will eventually come down with the more volume, but there is also like a big ecosystem around it. So connecting it to the previous point. Mm-hmm. So right now, because the need that everybody has for experts to program these robots, sometimes programming the robot is even way more expensive than the robot itself. So that's also like another headwind for mass adoption of robotics, which we are trying to improve the technology to lower the barrier for entry.
You spoke about cost and accessibility, which is a great segue into my next question. So as you and your team have made these breakthroughs within robotics, how can those breakthroughs really make robots more commercially available for the masses?
Mm-hmm. So right now we are doing most of our tech transfer like to products through partnerships with NVIDIA. So there are these like there are external companies partnered with NVIDIA on like different areas, and we are working with them. To basically transfer our technology and deploy it in their companies. So that's one way, through partnerships. The second way is that it's kind of more organic. So for a lot of our research, we release the code and model to the public. So we put it on GitHub, and sometimes they get picked up by other companies or startups to incorporate in their tech stack. Basically, so this has been like the two ways that we have been exploring so far. But we are also so NVIDIA is pushing like a new ecosystem that we are going to add more and more technologies to it. So it's called ICRA. So it basically has these gems that are built on top of ROS, and they are enabling different capabilities.
That's fascinating. I've got my manufacturing hat on, right? With many of the folks that are joining this call here. So what other opportunities are out there for manufacturers to learn about the advancements going on in robotics research, or even maybe have the opportunity to participate and innovate with teams like yours?
So that's a very good question. So let me answer the first one first. So if you want to learn about the latest in robotics research, so there are some major conferences happening annually. Like there are 3 or 4 top conferences for robotics researchers. So the first one is called ICRA. So it's like it usually happens in September. No, the deadline is in September. It usually happens in May, and between May and June. The second one is RSS. So that's also, sometimes it is in US, sometimes it is abroad. And another conference is called Coral, so Conference for Robot Learning. So these are conferences that are very technical for robotics researchers, but of course there are these like robotics robot trade shows like Automate, ProMat, and others, but those are kind of more technologies that are more mature and more integrated into products. So for research, so the conferences that I talked about are mostly for research, but trade shows are also a great way to catch up with the technology that is ready to use. And in terms of collaboration with NVIDIA, so we do a lot of collaborations with different companies. So basically, the way it goes is that there needs to be some agreement between the business part of NVIDIA and the external collaborators first, to kind of establish that whether it's a good fit and also like a suitable partnership. And then we basically get involved with product teams to basically develop the technologies that can address these underlying problems. And also the product team works on the productionization of those technologies.
And if you could talk a bit more about the future of robotics, right? So give us a glimpse into your vision on where you see robotics going into the future, and ultimately the impact it will have beyond manufacturing, but ultimately the world.
Yeah. So I feel like I'm actually quite convinced that robotics is here to stay. Like there are a lot of contributing factors to it that I can go over them briefly. Like the first thing is that the birth rate is decreasing in almost all the countries, which means that we will have aging population and shrinking workforce. And the second thing is that like younger generations don't have like the preference or enthusiasm to do like some of the sectors, some of the jobs in sectors of economy. So we need somebody. So we need a way to be able to do to still accomplish those tasks, and all of these reasons, and also like especially after COVID, it seems like a lot of countries are moving away from relying on just global supply chain and moving toward more local supply chain, which also adds more pressure for adding capacity for like manufacturing. So these are all the tailwinds for basically increasing the adoption of robotics. But in general, I think as soon as we make the robots more accessible or more easy to program for everybody, I think it will explode in all the other areas. Like, for example, if you look at today, like restaurants are always in shortage of, they are in shortage of like people to hire. Like, and they are looking for solutions. Like, for example, you can imagine that you can have like restaurants where the kitchen is fully automated, and you can have these kitchens run 24/7. So even like during night, you can just go, like any time of the day, you can go and get your food. Or like for elderly care, like we won't need people to go to special areas to get care. Like we can provide care for elderly people at the place that they are living, without the need to move. So these are kind of far in the future, but I feel like this is the direction that is inevitable. Like we need these changes, these advancements to happen, because there is a need that we cannot fulfill that gap, basically. Yeah.
Arsalan, that was a fantastic vision and a really great encapsulation of the tailwinds that are moving robotics. And I'm curious, from your point of view, often what we see about robotics and robots is what's happening at Boston Dynamics.
Yeah.
And they're showing, all kinds of different, robots, and they're not doing complex tasks like we need in industry. But what are your thoughts about other groups like Boston Dynamics and the type of robotics they're working on?
Yeah. So Boston Dynamics is like a really great team. Like no need to like it's obvious that they are doing great work, but they are mostly working on at least so far they've been mostly focused on like, for example, control aspect of the robotics, like, for example, how to balance the robot, how to do parkour. But behind the scenes, most of their effort is kind of tailored toward the environment that they demo the system. So they have been more focused on making a very amazing, capable platform, and less on like perception and manipulation. But I think they are also moving into that direction to make it better. So so that was about like Boston Dynamics, because you just mentioned it. But basically, in general, in order for this system to become more versatile and more useful in different areas, we need to train these models with the mindset of deploying them in an uncontrolled environment. Like oftentimes in research, we basically show these amazing capabilities, but we kind of show it in the environments are usually very clean and very well lit in the labs, but that's usually not the case in manufacturing. So I feel like if manufacturers also advertise the limitations that, or like the conditions of their factories and like manufacturing sites, and also come up with a set of like open problems, like okay, we have a need for these kind of problems, but we don't have a solution. Like that would also help a lot, because in research most of the times we are trying to glean information from manufacturers and like what kind of problems are important or what are the bottlenecks, so that we ask the right question in the research. But if more and more people and researchers are aware of the issues that manufacturers are dealing with, then that would make it easier for them to invent a technology that is useful for manufacturers. And I've been and just a quick follow-up on that. I myself, as I told you before, I'm very happy to learn about like issues and like the use cases that manufacturers have. So if anybody is interested, I live in Seattle. I can come to like any sites in Seattle area, Kent, Tacoma, like anything that is like reasonably drivable. I'm more than happy to come and see the use cases, because that inspires us to guide our research to solve real problems that move the needle for manufacturers.
And Arsalan, I'll just mention, because it might be helpful for people to know that you and I went to visit Boykin Metals.
Yeah.
Nick Hanela and his group over there. And I thought it was great, the questions that you asked, but also the insights that you both shared. And so if anybody's listening to this and you know, they feel like, you know, they could do a tour with Arsalan, I'd be happy to set that up.
Well, this topic is so fascinating, and I can talk to you for hours, but I want to make sure that we save some good stuff for your presentation at the Innovation Forum on August 2nd.
Yep.
So we definitely want to make sure that we capture that and have you present for the next meeting. Definitely. But again, Arsalan, very much thank you for joining us today and providing a preview of your presentation. We'll be sending this out in advance for folks to view and watch.